Alright, so like I said, this is like having variables. You've got, if you ever find yourself in a program and you find yourself using multiple variables that are the same type, perform the same function, you may want to create an array. An array looks like this. Let's say I have int, let's say it's item 1, and int item 2, int item 3, if you find yourself doing something like that, that's your cue. A little flag in your head should go off and say, you know what, I should be using an array. And by using an array, it can normally reduce the amount of code that you write quite a bit. Sometimes you can do it all at once. So like the last lab, you've written out, how many lines of code in the last one?
I think for me it was like 700.
700?
Like 4 or 5.
Should be about 4 or 5. 400 or 500 lines of code. It should be about that. If you use a lot of white space, it might have gotten longer, or if you did it wrong, or did it the hard way. Anyways, you could probably reduce that by a factor of, well, we had 6 employees, so you could probably reduce it by a factor of 6 if you used an array. And the way we would do this with this example right here, instead of saying item 1, we're going to put item there, and then we're going to put a pair of brackets. And inside the brackets, you write how many of this item that you want. So if we wanted 5, we could put 5 there. I consider 3 to be the threshold. Like if you only have 1 item, you don't need an array. If you have 2, you know, you go to the trouble to make the array, or you just write everything twice. It's kind of eh. But if you've got 3, you might as well go ahead and make the array. That's my personal preference. Here we've got 5, so definitely want to use an array instead of writing out separate integers for 1, 2, 3, 4, and 5. Okay? And like I said, with an array, everything must be the same data type. Everything in this case is an integer, but you can have an array of anything. You could do an array of strings, you could do an array of floats, an array of bools. You can have an array of anything. You can even do structures. If you've got a structure, you want to create an array of objects from that structure, you can do that. And this creates 5 of whatever I've specified here, and it creates them all right beside each other in the memory, and that's important. Okay, every memory location has an address. These will all be physically located next to each other. That's important later on, and it won't seem important at first, but when we get to pointers, it becomes important to know that. All right, now if you want 5, you put that number here, but an array starts at 0. So if I have 5 integers in this array, I only have 0 through 4. I can never access item number 5 when you start at 0. 5 does not exist. But if I do want to access item 0, I would just do that. I can say item brackets 0 equals some value. Or you could read that in. You could say cout item 0 and display item 0. So let's run that, see if it works. I did not set my subsystem. There we go. Item 0. 10. Should have done, forgot my end line. There we go. You just treat it like a normal variable, and you always have to put the brackets on there and indicate which item you're talking about. Let's, instead of hard coding this, let's ask the user for the value of the item. See out, enter the value of item 0. We don't need that. And then I could do a CN to item 0. Just like you would a normal variable. And then you could display the contents of that item. If we run that, that works just fine. So why is this better than just creating 5 separate variables? It's about to be less typing. I haven't shown you how it's less typing so far, except for that. I created 5 without actually typing out 5, but yeah. Now this works for 1, but if I want to do it for all of them, we can wrap this in a for loop, and arrays and for loops go hand in hand. So for index I, so int I equals 0, we'll say I less than 5, because there are 5 elements in our array. By the way, each item in an array is called an element. It doesn't matter what you have in your array, if it's integers or objects or floats or whatever, they're all elements. The position in the array is the index. So right now we've specified index 0, and that's good for the first one, but if we want to do all of these in a for loop, we can take out 0. We know that I starts at 0, so we can put the I in there. And the same thing here. And then it will run through and it will access element 0, and we'll get the input for that, and it will display the result. And then the for loop will take I up a notch, so we'll get to element 1, and it will ask us about element 1, display element 1, and that should work just fine. Tell you what, let's take this line out, and we'll put it in its own for loop. So what do you expect to see for output when we run this program? Yeah, that's kind of misleading, isn't it? Because it's not going to be item 0. What's it going to be? Item I. So how do we fix that? We'll close that string, put an insertion operator, put an I, and another insertion operator. And another set of quotes. Now I will update with the loop. So it will ask us 5 times, basically for 5 values, and then it will display, got the same problem right here, not 0. I will display the value of the 5 items. Alright, so run that. We'll just type in some random values here. And then it shows them all to us. Everyone successful?
I did something wrong.
Significantly less code than if you had to write this statement 5 times, get this input 5 times, and write this cout statement 5 times. Now there's a little bit of overhead. We did have to write a for loop, but it's still less code than if we had to write everything individually. And furthermore, this is pretty flexible. We could go up to 50 real quick, you know, just like that. And now that's way less than if we had to do 50 of these guys individually, right? And so arrays can make life a lot easier, especially when they're coupled with for loops in the right context. Another interesting thing about arrays, an array is permanently sized. When you run the program, that array cannot change size. So you cannot designate the size of an array with a variable. So if I came up here and I said int size equals 5. Okay, I cannot put size in here because that would suggest the size of this array could change. If I change size, that would change the size of the array. That is illegal. So they are fixed from the time the program runs. You can, if you did want to, we could do const. What does const do? Constant cannot be changed. Alright, now we've told the compiler we will not change size. It is absolutely fixed. Then we can use size in place of the array. And I could change all of these to size. And now if I, the programmer, do need to change the size of my array, I can change it right here in this constant variable, and that changes it everywhere. And I went from 5 to 50 just by adding a 0 there. And that works just fine. So if you do want to use a variable to change the size of your array, you do have to make it constant. Or something very similar to making it constant, you can write a macro. So I could do, normally you'll see these up above the function, pound define size. And how big do you want it? 50. And that does the same thing. It's actually a little bit different. Before, we had a variable. Even though it was constant, it's technically a variable, and it is stored in memory as a variable, just like any other variable. What we've done here is we've sent a directive to the compiler. The compiler is the program that converts our C++ into ones and zeros. The directive says, hey, anywhere you see the word size, replace that with a 50. So there's no variable created this way. This is actually a little more efficient at runtime. The compiler just does a copy and paste operation, but it's still easy for us to change the size of our array in one place, you know, just by changing it right there at that macro. So pound define, that is a directive to the compiler. And you can use those to size your array because it is literally just, it's going to do a copy and paste operation when we run this thing. It's going to drop that 20 in there everywhere that you see size. If you run that, that works just fine. Note there is no semicolon on the end of that, which is kind of weird. If you put a semicolon there, it will paste the semicolon in there with it, so don't do that. All right, any questions about arrays so far? Let's do another example. Instead of integers, let's do employees. So let's create our employee structure and give our employees some information. What do they need? A name, a rate, hours, gross, and net. We won't worry about net. We're not going to do taxes. We'll just say we take home everything. Alright, so I've got my employee structure up here. And in main, let's say my company has 5 employees. I can create an array of employees just like I created an array of integers. Say employee. And I'll just call it E to keep it short, but you can call it whatever you want. You can write out lowercase employee if you want to. And then I'll put size in there. Or you could hard code it and just put a number in there. I said we had 5, let's just make it 4. Size is now 4. And now if I want to process the payroll for these guys, I can do that in a for loop. So for int I equals 0, I less than size, I plus plus, cout, enter the name, okay, I need the first employee's name. What do I put here?
Bartholomew.
No.
Joe.
Huh?
Joe.
I'm going to take in a name. I don't need the name itself. I need to code this so that a name can be entered and it will be stored in my array.
E open bracket, I close bracket, dot name.
Name. E sub I dot name. We can do the same thing with the rest of this. We'll enter the rate the same way, and the hours. And we can calculate the payroll. And everywhere I need to access an employee, I'm typing E sub I, and then I use my dot operator to get to that value. Gross equals, if I've got more than 40 hours, it's going to be 40 times the rate, right? E sub I dot rate. Plus the overtime. So E sub I dot hours minus 40 that in parentheses times E sub I dot rate times 1.5, time and a half. And otherwise, E sub I dot gross equals E sub I dot hours times the rate. I've got all that in my for loop now. We'll display the gross. Alright, so I've got the payroll program worked out for the entire company regardless of how big it is. Because I've got an array and I've got a for loop that works well with it. And if I need more employees, I can go over here and change my size to whatever I want, and we can process payroll until we're blue in the face. Let's try it for 4 though. Let's make sure this works. Okay. Fred. Rate $10 an hour, works 40 hours a week, makes $400. Go to the next guy, enter the name, Sally, enter the rate, $10 an hour, works 45 hours, made $475, works just fine. And we can do this all day long. But we've got 4 employees, I hope. No more than that, so we got Joe, he makes $30 an hour. Works 40 hours a week. And Bob, he's like the CEO or something. Makes $1,000 an hour. Works 80 hours a week. Makes all the money. No, you don't want Bob's job. He works 80 hours a week.
He also gets 100,000 a week.
That's irrelevant. That's a sad life. His kids probably don't even know who he is.
Money, you'll never be able to spend it, so you never have time.
Never seen
Yeah.
I mean, you have the money.
You'll have the money that you never get to spend. Alright, so do you see how the array works? Do you see how that can simplify a lot of our programming? We can use it with primitives, we can use it with strings, we can use it with structures. You can use arrays with all kinds of stuff. Okay, you can initialize arrays from the beginning. Let's just go back to the simple array int num. Let's say I've just got 5 numbers here. Okay, you could do that. And if I wanted to initialize these guys, I could do it in a for loop, or I could say num sub 0 equals this, and so on. Or you can do it like this. You put an equal sign there and you open some curly braces and you just fill out the values with commas in between them. So if I want my first number to be 10, I'll put that. My next number to be 4, I'll put that, and you get the idea. So let's just put 5 numbers in here, and then my array will be initialized accordingly. And a semicolon on the end. So if I see out num sub 2, what do you expect to see? This may be on the test.
45.
45. Right? Because element 2 is the third element. 0 is 10, 1 is 4, 2 is 45. So let's see if we're right. Hey, good job everybody. So you can initialize an array like that. You can also initialize a structure in a similar way. Okay, arrays also exist in 2 dimensions. Now in the memory doesn't have dimensions, it's just a long line of addresses. So this doesn't necessarily echo into the memory like this. It kind of wraps around. But within the code, you can create two-dimensional arrays. And when you think of a two-dimensional array, just think of, instead of a chain, think of a grid. So I'll call it grid, and we'll make it a 2 by 2 grid. So it looks like this. All right, and we've got rows and columns. The first number you can take to be the rows if you want to. This is all in your head. Okay, this is all an idea that just works really well. In the memory, it's going to be looking like this. We're just going to have 1, 2, 3, 4 addresses. But you can think of it as a grid, and you can think of it as rows and columns. So that first bracket will contain a 0 and 1 for this row. It's like Battleship. And then the second bracket will contain the columns. So you can do it like that. As long as you stick with the same convention throughout your program, this works. You can think of it this way. Don't get your rows and columns mixed up. Pick a convention and stick with it. But then, so there's drawbacks. If you're going to use a 2D array, at least for right now, you will always have to use both indices anytime you reference that array. So grid 0, 0 equals 12. If I put that in there, that's like me going over here. I go to 0, 0, and I put in 12. And then, you know, I could say grid 1, 1 equals 23. And that's the same as if I went to, that should be a 2, that should be a 1, sorry. 1. So I go to 1, 1, and I put in my 23. And then I can use cout the same way. Check out 1, 0. What do you expect to see for output? 12? Let's see. That's not 12. That's not 12.
The address of it.
It's not even the address. It's at 1, 0. What's at 1, 0? Nothing, right? Whatever value was left in there by some other program or whatever the operating system initialized it to, we call that garbage. Literally, that is the term for some value like that that just happens to be there. It's whatever position those bits are in, that is garbage. All right, what if I do this? We'll change that to a 2. Now what do you expect to see? I don't know, what do we get? No, it's more garbage. Where would this value be?
3-dimensional?
No, we'll get there in a minute. We're still 2 dimensions. It's just like 1, 2. Where would that be? That's like row 1, column 2. It's like this. That doesn't even belong to our array. We're accessing memory that could be a part of some other program. What does this code do?
It's going to give us garbage, then 23, and then more garbage.
We're going to hit 1, 0. And she's right, that's garbage. And then we'll get our 23, and then we'll get 1,000 pieces of garbage, or we'll get into memory that belongs to another program, and we'll see what they have in their memory, or it'll crash. Oh yeah, look at all that. We're like hackers now. We're invading other people's memory.
2, 0, here.
Isn't that cool? What is this 100 doing here?
Nobody knows.
116.
I don't know. Anyways, that's what we're doing. We're like just browsing through the memory. So be careful with your arrays. Make sure you stay in the bounds. Don't go changing other programs' memory. You can try that. C++ doesn't have a lot of guardrails like most other languages. You can go out and do crazy stuff with it. If you try doing this in C# or Python or something, you would get shut down. You're like, no, that's not your memory. You can't do that. But in C++, you can break the rules a little bit, but don't do that. Your program won't work right. So there's a two-dimensional array. You want to use the two-dimensional array, or at least consider it anytime you're working with a grid. So if you're writing a checkers game, right, you got an 8x8 for chess. Or Battleship, you've got a 10x10. Or sometimes people do this for spreadsheets. You know, you've got rows and columns on a spreadsheet. So that might be another place for it. But we use them in the artificial intelligence class where we want to set up a big grid for pathfinding. You make a big 2D array of squares, and you know you teach your agents how to do pathfinding across that grid. So 2D array and grid, you want to keep those in mind. We can do a 3D array. All right, this gets really cumbersome to work with, and I don't recommend making a 3D array, but you can. I'll get rid of our crazy for loop, our invading for loop. And all right, so we've got a 2x2x3. Conceptually, what does this look like? Again, in the memory, it's just going down. The address is here. But in your mind, if 2D array is a grid, what is a 3D array?
A cube.
It's a cube. Right, so if you wanted to, you could think of it as some kind of cube here full of cells.
And each cell is its own number?
Yep, each cell is its own three-dimensional number. So with that array, how far do we go back? Go 3 cells back. So I can't draw all of that, but you get the idea. And if we wanted to access one of these guys, you'd have to give these numbers, or these sets. You know, this could be 0, and this could be 1, and that could be 2. And then if we go to 0, 1, 2, that would be this guy back here. All right, you don't use these very often, but you totally can. And they do have some applications in 3D projects. You can't draw that. It's a hypercube or whatever, but you can make it in the code. In fact, there's no limit to the number of dimensions you can put on your arrays, but don't ever do that. Because it'll be a pain to work with, and there's just probably a better way to do it. But if you're asked on a test how many dimensions can you add to an array, well, there is no limit until you run out of memory.
Well, we could use a 3D
A 3D array?
Well, 3D grid, what would you use it for? Yeah, 3D array.
I wouldn't use it for anything.
Well, what would you use it for? Yeah.
I don't know. Where do you have? Oh, Oh, 3D Connect 4.
That'll be interesting.
Let's do it.
I don't know.
Okay.
I
3D chess.
just one last thing on multidimensional arrays. You can initialize those all at once as well. So if we had this 2x2 here, and you can do this with 3D arrays also. You can do it like this and then go ahead and make 2 more sets of brackets and then put a comma in between them. Okay, and then here's our first row, 1 and 2, and here's our second row, 3 and 4, and then it ends with a semicolon. You know, you could do that. That should give us our 4. Works just fine. And if you wanted to do a 3D array, you would wrap these up in their own little set of braces and then comma more sets of braces and get as crazy as you want with it. Some people, it's easier to do that. Let's say it's a little bigger. Let's do a 4x4.
Oh boy.
You could do your first 4 numbers right there and then drop down. Do your next row of numbers. And then you're kind of laying it out according to your own little convention. And you keep going like that, and then it's actually laid out like the grid itself, so it's easy to visualize. And there's a few applications where something like that can come in handy. I've seen it done a few times. So any questions about multidimensional arrays? That's pretty much it. We'll talk about strings real quick. The book has a lot of stuff on strings. There's a lot of neat little functions that are already built in that work well with strings. If you want to find a set of characters in a string, if you want to, I don't know, read a string backwards, there's a whole library full of string functions you can use. But we put strings and arrays together because a string is an array of what? Characters. Right? Character is the primitive. Char is the primitive. We put a whole bunch of them together side by side. You get a string. So an array of characters is called a C string. Normally you see it written with the asterisk. And C++ has made it easy so you can actually just initialize it instead of using the way we did it with the other ones. If I had to write my name, like if I had to initialize my name like this, it would be pretty painful. Right? That's terrible. It would work, but that's not ideal. This is ideal. So there's provisions for that should work. I think maybe not. There we go. That works just fine. Notice I don't have to specify the size, and I can just assign a string directly to it, and C++ will take care of the rest. This is called a C string. It is just an array of characters. The string from the string class, like we used up here in employee, is an object. It is from the string class. Class is like a structure. There's other stuff that come with it, like the length. And so there's the difference between a string and a C string. Now the string object, I'm talking about this one, contains the C string. The C string will be a part of a string object. But you can extract the C string, you can extract the character array all by itself if you want to. So let's say I've got a string name equals Bob. No, Bob, there we go. And then if I wanted to, I could see out C underscore str. That's a function call that will extract the character array from the string object. So sometimes in C++ you find yourself working with old C code. Like a lot of the libraries we use are written in straight C and they do not accept string objects. You will need to extract the character array. Because in C, that's all they had was the character array. They did not have the string object. And so the C underscore str function will extract that for you. There we go. Works just fine. And so in this case, cout can work with either one. You don't have to extract the character array. I'm just showing you that's what it does.